Hey everybody, and welcome back to Frontend Expert. In this video, we will be discussing DOM manipulation, or how we can interact with the DOM using JavaScript. So in this example, we have some basic markup. First, we have an ordered list with 3 list items, the second of which has an ID of second li. And then we have this div with the ID of scrollable, and it has a bunch of paragraphs inside of it. And if we look at the output, first we have the 3 list items, and then we have the scrollable div, which using CSS we have made be a scrollable container. And we can see the CSS we have written here, but we won't be needing to use this too much. But the most important thing here is that we have these 2 classes that we aren't yet using, and we are going to see how to add these classes dynamically using JavaScript. And then we have the ID of scrollable and the styles to make this scrollable container. We've set it to position relative. We'll see why we did that in a moment. And then we have a background color just so we can see it, a height of 70 pixels, some border padding and margin, and then we have overflow set to auto, which simply says that if the content is larger than this height, then instead of just not showing it or overflowing from the container, that we want to have a scroll bar, and that is what we have in the output. Okay, so now let's move over to our JS file and start seeing how we can manipulate the DOM. The first thing I want to look at is how we can start selecting elements, and we have a few different functions to do this, and all of these functions are on the document object. And the document object is something we're going to be using a lot in this video. It contains most of the functions for interacting with the DOM. So, for example, we can say document.getElementById first, and what this does is it takes in an ID and then returns the element with that ID. So for example, if we go back to our HTML, the second list item had the ID of second li, so we can copy this ID and we can paste it into document.getElementById, and let's save this in a variable, so we can say const second li, and set this equal to document.getElementById of second li, and for now let's just console.log second li. And now you'll see we log out to the console, the second li list item. And if we come over to the console here, we can see the list item that we printed out. And if we open it up, you can see the list item 2 contents, as well as it has this marker pseudo element, which adds the number 2 before the actual contents of the list item. Okay, so next, what I want to look at is a few more of these functions we have to get elements. So not every element is going to have an ID. So what we have to be more generic here is document.querySelector. And what querySelector does is it takes in a CSS selector as a string, and it returns whatever element that selector would select. And if that selector would select multiple elements, it just selects the first one. So for example, we could do li, and let's save this as a constant as well. So const, and we'll call this first li, and set this equal to this query selector, and we can console.log first li, and again, this is going to select the first one just because it selects the first element in the page that matches this li selector. And now when we run this, you'll see we get the first li, and then we have the second li directly after it. And we can open this up in the console as well to see that it is getting list item 1. Okay, so now you might be wondering, what if I wanted to get all of the elements matching a selector? And we have a function for that as well. So we can change this to querySelectorAll, and I'll change the name of the constant to, let's just say, list items. So what document.querySelectorAll is going to do is the same thing as document.querySelector. The difference being that with querySelectorAll, we're going to get every element matching the selector rather than just the first one. And it's going to get these as a node list, which is an iterable, so we can do a lot of things with it that we can do with arrays, but we don't have all of the functions of an array, and we'll see that in a moment. So here we have the list items constant, and we can console.log list items, and I'll get rid of the other console logs for now as well, just to make things a little bit easier to see in the console. So let's say list items. And you'll see now we get this node list, and it has 3 elements in it. It has an li, then it has li with ID second li, and it has a third li. And if we open up the node list in the console, we can see the 3 different list items, as well as it has a length of 3. Okay, so now let's come back to the JavaScript and let's take a look at some of the functions of the list items. So we saw we had the length property first of all, so we could say console.log of list items.length, and what we're going to log out is going to be 3. And next, we have this function list items.forEach, and this is going to work the same way as forEach on an array, so we can pass in a arrow function, so we can say list item, and we want to, let's just say console.log each list item, and what this is going to do is log every item in the list, and now you see we log out all 3 of the LIs. But it is worth noting we don't have all of the array functions here. So for example, we don't have a map function, so if we try to do this, we just get listItems.map is not a function. So do know that forEach is really the only major function we get here for these node lists. But if you did need to use map, what you can do is you can say array.from, and this is a way to create an array from an iterable. So then we can use this as an array. So I can say array.from, and then we can use map, and it's going to work just like standard map functions do on arrays. Next, there are a few other functions of the document that we can use to get elements. So along with query selector all, we have a couple others that get multiple elements. So we can say, let's just console.log document.getElements by class name. And what this does is it takes in a CSS class. So for example, if I put list item, it will select all of the elements with that class. There isn't currently any element on the page with the class, but if, for example, I added the list item class to the first list item, then we end up getting an HTML collection with that one list item in it. Okay, so now let's get rid of that class and come back to our JS. We also have get elements by tag name, and get elements by tag name is going to take in the name of the tag. So for example, we can do the list item tag, and this is going to give us an HTML collection with the 3 list items. Now, I usually don't recommend using these functions, and the reason is the HTML collection they return is just not as powerful as a node list. So for example, let's save this in a variable. So let's say const list items. We can save that and get rid of this extra parentheses. And we can't actually say list items.forEach now. So we need to comment out this one so we don't have 2 of the same constant. But for example, list items.forEach, and then we could pass in the li like we did before and say console.log of the list item and add some semicolons. And this actually is going to throw an error because the HTML collections doesn't have a forEach function. We could, of course, do the same array.from that we did before, and this will work fine. But why would we do this when we can simply use document.querySelectorAll, and then we don't need to do array.from to use forEach, which is by far the most common function that we end up needing to use. Now let's remove this code and go back to the querySelectorAll list items that we had before. Okay, now I want to look at how we can start actually editing these DOM nodes. So let's get the first list item. So we can say list items at 0, so we can use the array syntax with a node list, which is nice. And let's get the style property, which is going to contain all of the inline styles, so all of the CSS styles that are inline on the element. And then we can set the properties here. So for example, I can say style.color, and I'll set this equal to red, and you'll see that now it's going to make the first list item red. And we can set any CSS properties here. So for example, I could set the background color to be blue, and now we'll get a blue background color instead of the red font. We can also change the actual text of the list item. So instead of doing style, we can do .text content, and this holds the content of the node, so the text inside of it, and maybe I want to put this to changed. And now you'll see we end up getting changed instead of list item 1. One property that's particularly interesting on list items is the value property. And this is going to affect what the value is in the order of the list items. So now this is starting at 5. So we have 5, 6, 7 because of the fact that list item 0 is 5 and all of the list items after that just add 1 by default, so their values became 6 and 7. Next, we can also use this function setAttribute, which takes in an HTML attribute, such as the value attribute that we were just setting. So value is actually an attribute we can set through HTML. Then we pass in the value. So let's say 7, and we usually pass these in as strings, but if you don't pass it in as a string, it's just going to get converted for you. So it doesn't really matter which one you do, but you'll see now we have 7, 8, 9. And we can actually use setAttribute to set any attribute. So I could change the class, for example, and come over to our CSS and copy maybe this blue class, which sets a color of blue, and put it here. So for the value, we will have blue, and now you'll see we end up getting blue text. And just like we can in HTML, we can have space separated classes here. So I could set this to blue and also give it the big class, which is a class here, making the font size 2EM. Now that said, this usually isn't how we want to manipulate classes. So what we can do instead is we can say list items at 0, and we have this class list property, and it has a few different functions that we can call. So for example, I could call classList.remove, and let's remove the big class. And now you'll see we're back to having just blue. So this added big and blue, but this removed the big class. So now we have just blue. We can also use classList.add. So I could add blue, for example, even if I didn't have it here. So this first line is now setting the attribute to just big, and the second is adding blue to it. And even if we got rid of this line, we still have blue, just not big, and we can call this multiple times. So I could add blue as well as I could add big in a separate call to classList.add. And alternatively to this, we can actually just pass both classes in as separate parameters to this function. So I could pass in big and blue, get rid of this, and this will work the exact same way. And lastly, we also have this function list items 0.classList.toggle. And what toggle is going to do is if the class was already there, it's going to remove it. So now we have removed big, but if it wasn't already there, then what it's going to do is it's going to add it. So now you'll see we end up adding big. And if we toggle twice, this essentially does nothing because it has added it on this line and then removed it again. And then of course, if we add it a third time, it will have added it back again. And finally, there is one last way that we can change a class. So we could say list items at 0 and just say .class name. And then in the class name, set it equal to whatever we want the class name to be. So for example, blue big, and this is going to be just the class attribute value in HTML. And we can get rid of all of these, and this will do the same thing. Or we could just do blue, for example, and now we have just blue. I usually wouldn't recommend doing it this way, though. Usually we want to use the functions we've been given rather than editing these properties manually. So the class list object with its functions is usually the way to go. This also prevents us from accidentally overriding some classes. So with this, it's going to delete any previously had classes. So for example, if I'd set the attribute to big, and then I use class name and set it to blue, this is overriding the class name property rather than adding to it, versus if we add to it using classList.add, we end up getting both, which is usually what we would actually end up wanting. Okay, so next, let's move on from classes and let's look at how we can actually create our own DOM nodes. So I'm going to create a paragraph. So let's say const, and we'll call this P for paragraph, and we can call document.createElement. And what this does is it creates a DOM node, and we pass in what tag we want to create. So for example, I will create a paragraph tag, but this isn't going to do anything in the sense that it isn't going to affect the page. So when I save this, nothing is going to appear on the page. We have no new paragraph. So simply the paragraph element is saved here, and when we need it, we will add it to the DOM. But first, let's start editing this paragraph a bit. So I can say paragraph.textContent to set the contents of the text, and maybe I say hello world here. And then we need to start adding this to the DOM. And there are a few different functions we can use to do this. So what I'm going to do is just add this to the body. So we have document.body, which is essentially the equivalent of doing query selector of body. And what we can do with document.body is we can call append child first, and append the paragraph. So we're passing in the actual paragraph constant into document.body.appendChild. And now you'll see we get this hello world text is appended to the bottom of the document. Now we can also do document.body.append, and in this case, it's going to work the same way, but there are some key differences. The biggest one being that append doesn't actually need to just take in a tag. It can also take in text. So for example, if I did append test, it's going to append the text test, but it hasn't created a paragraph tag here. It's just stuck the text test into the DOM. But for now, let's go back to our paragraph. And append can also have multiple arguments. So I could do the paragraph and then I could do test, and we end up getting both. But again, the test is not creating a paragraph. It's simply just adding that text directly to the DOM. And for now, we will go back to just our paragraph. And we also have a function prepend, and this works the same way as append, except it sticks it at the beginning. So now we have hello world at the beginning of the body rather than at the end. And one other option we have here is instead of setting the text content, we can actually create a text node and append that. So I could say const text equals document.create text node, and then we just pass in whatever text we want, like hello world. So what I will do is instead of paragraph.text content, we can do paragraph.append text, and this text will be added to the paragraph, and we get the same output we had before. Now there is one more alternative here, and that is using what we call inner HTML. So inner HTML is a property of elements that contains all of the HTML inside of it as a string. So let me show you what I mean. Let's do console.log list items at 0.inner HTML. And what this is going to log out is the contents of list item 1. And if, for example, I did instead the inner HTML of, let's do document.querySelector, and let's do the entire ordered list, then you'll see the entire text of this ordered list as a string is being printed out. And this inner HTML is actually editable. So let's get rid of this console.log. Now what we can do instead of the code we had is we can say document.body, but we're going to get its inner HTML, and we're going to concatenate to it, which is essentially the same thing as appending to the end of it. And we're going to concatenate a string representing this paragraph. So we can just write HTML in this string. So let's say HTML test string and close out that tag. And we can add the semicolon here. And what you'll see is we have appended HTML test string to the end of the body. Now, most of the time, I would recommend not doing this. The reason being it's just super bug prone. There is so many ways to create a bug by doing this. You are not going to get the nice features of the text editor that you're using for telling you if you're missing a closing tag, for example. And it's just an easy way to introduce new bugs. So most of the time, I won't be using this. One thing that is worth using with inner HTML, though, is if we set inner HTML to an empty string, this actually clears out the entire element, so everything's gone now. And this is kind of useful sometimes. If you have a container and you need in JavaScript to just remove all of the elements from the container, this is oftentimes the easiest way to do that. So I do encourage you to use inner HTML for this reason, but most of the time I would avoid it. Now there is one scenario where I would say absolutely never use inner HTML, and that is when you're using some user input. So for example, if you were displaying user comments on the page, because a user could do something like add a script tag into their comments, and then they could do something bad inside of that script tag, and the script will end up running on your page because of the fact that you just added the script tag to your HTML DOM. So in any case where we are allowing the users to control what is being added to the DOM, we want to make sure not to use inner HTML. We want to be manually creating the paragraphs, the text nodes, etc., to control what is being added to our page. Okay, so now let's remove this and get our HTML back. And what I want to show next is how we can add elements in a loop. So let's add a for loop, and let's say let I equal 0, and we'll do I is less than 3, and I++. And what I want to do is in this loop, I want to add list items to our list. So what we need to do is say const li, and we're going to say document.createElements, and we'll create a list item. And then we can give the list item some text. So let's say .text content. We could also use create text node if we want. And let's set this equal to a template literal that is list item with I equal to, and then the value of I. Okay. And now what we need to do is actually append these to the page. So what we can do is we can say const parent equals document.query selector of the ordered list. And we need to append to that ordered list. So parent.append li. Okay, so now this is going to work. We get list item with I equals 0, 1, and 2 added to the end of our list. But there are a few issues here, and it's something that can come up a lot, so I wanted to demonstrate it. First, inside of this loop, we're doing a few things that are a bit expensive. So first, we get the ordered lists out of the document, and this isn't to say the browser isn't efficient, because it's incredibly efficient, but we should still be writing efficient code, and we don't need to be calling this document.query selector in every iteration of the loop. So whenever a substantial function call inside of the loop isn't dependent on being in the loop, we should usually move it outside so we only have to do it once. So I'll move this to the outside of the loop, and nothing's going to change. And another thing you might notice is we are appending to the parent in every iteration of this loop. That might not seem like that big of a deal, but what it means is that in every iteration, the browser is having to render the page again. And if this loop was much bigger, it would actually be an issue. So there's a few ways we can solve this. The first option is we can create a list. So I can say const, and let's create list items to add, and just create this equal to an empty array. And then instead of appending the li, what I'm going to do instead is say list items to add dot push, and we're going to push the list item, and we can get rid of this parent.append. And finally, what we can do is we can say parent.append, and we can spread the list items to add. And what we're going to get is exactly what we expect, except we only have a single call to append rather than appending 3 times. And alternatively, there's actually a built-in functionality with the document object that we can use here instead. So we call this a fragment. So I can say const fragment, and I'm going to do document.create document fragment. And what a fragment is it's sort of like your own little DOM, but this DOM isn't on the page, so it's not causing any renders. So now what we can do is we can say fragment.append of the list item, and if we just do this, nothing's actually going to happen. So this isn't going to add anything to the page because this fragment isn't on the page. Again, it's just sort of a DOM that only exists in JavaScript. It doesn't exist on the actual document. And now what we can finally do is say parent.append the fragment. And this is going to do essentially the same thing as the array that we had before, except we are using the built-in functionalities of the DOM API, which is usually a better option. Okay, so next, let's look at how we can remove elements from the DOM as well. So I'm going to come below this loop, and what I can do is say list items, and let's get the first element and remove it. And traditionally, the way we did this is we did .parent node, which gets the parent of the list item. So for example, if I just console log this out, console.log list items 0.parent node, you'll see we get the ordered list. So this is the parent of the list item. And then what we do is we call the remove child function of that item. So of the elements, we call the remove child function, and we pass in the element again. So we can say the element dot parent node dot remove child of the element, and this will end up removing list item 1. Now you might be saying, this is super verbose. This is a lot of code just to remove an element. And that's what a lot of people said. So they ended up adding a function to JavaScript or to the DOM API specifically, called remove, and this simply removes the element from the DOM, which is usually a lot easier way to do this, but I did want to show both ways because you might see both options, as well as there are still some very old browsers that don't support this. So if you did need to support every single old browser, then the old way of parent node.remove child of the child element is going to be the way to go, but most of the time you'll want to just use remove now, as it does have pretty good support across all of the modern browsers. Okay, so now let's remove all of this code and look at how we can actually get some sizes from the DOM. So we can do console.log of window.innerWidth first of all, and the window is an object we will use a lot that contains different properties and functions related to the browser window, and the inner width is going to get the width of the window. So if I console.log this value out, you can see we get 637, which is the width in pixels, but it does log it out as a number. We can also do inner height, and you can see this has a height of 353 pixels. Okay, but now let's take a look at some of our individual items. So let's go to list items at 0. And for example, let's get its font size. So we saw before we could do .style and then get whatever elements we wanted. So we could do .style.font size, and let's try logging this out. So we can say console.log list items 0.style.font size, and we get an empty string. Why is this? Well, the reason for this is that the font size is not being set on the element. So therefore, it's not on this style property. So what we need instead is to use a function called getComputedStyle. So what we can do is we can say window.getComputedStyle, and rather than getting the style set inline on the element or styles set in CSS, what getComputedStyle does is it gets the actual style. So what the browser is currently displaying. And we can say list items at 0. And now what I want to do is just get whatever we want off of this. So we can say .font size, and let's console log all of this out. So we can add a console log, and now you'll see we get 16 pixels as a string. Now the reason we get 16 pixels is because of the fact that the root element is set to 16 pixels, and that is the style that the browser is using for this list item. But what would happen if, for example, we did this list item.classList.add, and we had that big class that set it to 2em? Well, now we get 32 pixels, which is a little bit strange because in our CSS, big is 2em. So why are we getting 32 pixels? Well, the reason is that getComputedStyle is getting whatever style the browser has computed for it. And the browser knows pixels because pixels are the absolute size on the page. So it converts everything to pixels. And 2em is equivalent in this circumstance to 32 pixels. So that's why we get 32 pixels there. Okay, so next what I want to look at is the scrollable container. So let's say const scrollable, and set this equal to document.getElement by ID, and we can get the scrollable element. With this scrollable element, it's currently overflowing. So there's a few different properties we can use to get the sizes of this container. So first, let's do console.log of scrollable.client height. And what client height is this is the height of the visible content plus its padding. So if we console log this out, we get 90. And now if I go back to the CSS, we can see it has a height of 70 pixels and a padding of 10 pixels, which is going to give 10 pixels vertical on each side, which is 20 total vertical pixels of padding. So 20 plus 70 is where we got 90. So this is the size that is actually visible. But if we come down here and copy this, and instead of client height, we do offset height, what offset height is going to do is it's going to give us the visible height, but it's also going to include the border. So now we get 100 pixels because it's including a 5 pixel border on either side. So we have the 90 pixels from before plus 10 pixels of border. This would also include a scroll bar. If there was a scroll bar across the horizontal axis, then we would have the height of that scroll bar included in the offset height. And finally, one last height is going to be the scroll height. And what scroll height is it's the total height of the content as well as the padding, including the content that is currently scrolled out of view. So in this case, we have a total scroll height of 312 pixels on the scrollable container. And finally, one other useful property we have here is I could say console.log, and we can say scrollable.offsetTop. And what offset top is it's the distance from the outer border to the inner positioned parent border. So for example, in this case, offset top is 88, and this is actually just how far the scrollable container is from the top of the page. And the reason for that is that it has no positioned parent, positioned meaning having changed the position property. So it's just the distance from the top of the page, which is useful. But what we can actually do is we can use offset top to see how far individual elements are from the top of this scrollable container. So for example, let's do console.log, and we can say scrollable.querySelector. So we can query select within a individual element rather than just on the entire document. And let's actually do query selector all of the paragraphs. And let's just get, say, the fifth one, and let's console.log its offset top. So what this is going to do is it's going to say, get the fifth paragraph and see how far it is away from the top of the scrollable container. And if we log this out, we get 199 pixels. So the fifth paragraph is 199 pixels from the top. If we did, say, the first one, we get 26 pixels away from the top. So the reason we're getting 26 is because the default margin on the paragraph is 16 pixels, which is 1 EM. And then there's also 10 pixels of padding on the container. So 26 total pixels between the first element and the top of that container. Now, one thing that's worth noting here is if we don't have a positioned parent, so if we didn't have position relative here, then we're going to get different values. So now if I save this, we get 119, because this is now the distance from that paragraph to the border of its positioned parent, but it has no positioned parent, so it's now just the distance from that paragraph to the top of the body. But I will make this back to position relative again, and we will go back to our value of 26. And now what I want to look at last is scrolling. So scrolling is something that's pretty powerful within JavaScript because sometimes we need to automatically scroll the content. And there's a few different functions we can use to do this. So the first one is, let's get one of these paragraphs again, and maybe we get the fifth paragraph. And what we can call is this scroll into view function. So scroll into view. And all this is going to do is when I save it, you'll see it will automatically scroll the contents of the scrollable container down to where we can see that paragraph. And if I save this, you see now we've automatically scrolled all the way to the bottom of that container, but I haven't touched the scroll wheel on the mouse or anything else to scroll it. It is simply this code that scrolled this into view. And alternatively, we could call scrollable. So we choose which element we want to affect its scroll bar, and we can say .scroll_to, and this function is going to take in an object. And this object can have a few different options. So first I want to add a top, and what we're going to do is choose how far down we want to scroll. So let's choose maybe one of the paragraphs. Let's say we want to scroll to the second paragraph and its offset top value. And then let's set a behavior. And behavior allows us to say we want it to be smooth, meaning that we want the transition to happen smoothly rather than just jumping to the value. And now you'll see when I save, it smoothly transitions up to that second paragraph. And this scroll to function can be super useful when you need to automatically scroll the page. It is worth noting the smooth behavior is not supported by every browser. So in some browsers, if you add behavior smooth, it's going to be ignored. But in most of the modern ones, it is being used. And with that, that's going to be the end of this video on DOM manipulation. I hope you found it helpful. I hope you enjoyed it, and I'll see you in the next one.